Thank you. Thank you. Yeah, hello. I'm happy to be back in Florence. My name is Alexander. I'm work with the consultancy. We do strategic consultant on for startups in the industry, and my part is usually data science and tech, and not so much the business. Or for the community, I work in EuroPython for the program work group, and I also joined this year for the German edition, so the Deutsche PyCon this year, and yeah, and today we're going to talk about pandas. Do we have a pointer, by the way? No? Don't worry if we don't. You have a pointer? Yeah, yeah. Oh, that's super. Okay, thank you. Okay, today we're going to talk about pandas. What is pandas? Where does it come from? And uh, huh? Okay. Yeah, where does it come from? Pandas is made for practical real-world analysis. It's a very handy big tool set to analyze data, and it was built because actually in Python a data analysis library was missing. Okay. So it was missing, and many people for data analysis. Oh, okay, thank you very much. So test, yes. Okay. Okay, this goes back. Okay, it was built for a gapless workflow because many times in the past people had to change to the R language, which is like the language for statisticians. And now you can do everything within Python without leaving your workflow. It was started in 2008. It's now being maintained by Anaconda, like by NumFocus, the company behind Anaconda. It's very stable. It receives constant updates. It's an open source library you can rely on building future projects on. The main features are it supports all the common file formats. You can read in CSV, HDFS, you can Excel, whatever, name it. It's very handy for data cleansing. It's you can reshape and mangle your data. We're going to go a little deeper in this, and it has built-in data visualization, and it works very well with the Jupyter notebooks. So it's very handy just to use pandas and Jupyter notebooks to see what's in your data set, to play with your data set, to discover and explore it. It supports database-like operations. We will look into it a little bit deeper, and it's quite performant if the data set is not too big. So today we have two parts. So part one is like the basic functionalities. So if you're new or you just heard about pandas, this part is for you. So everybody is on track. And part two, we're going to go a little bit deeper into indexing and the time series analysis for this, because it's a nice example and how powerful the pandas index can be. We will spend about like 40 minutes on the first part, and so it's totally okay. If you know pandas, it's fine. I'm fine. Do whatever you want. Yeah? And on the second part, I will wake you up then. I will publish the slides later on GitHub. It's a little extended version with stuff I usually had cut out in previous presentations, so it's an extra remaster for this conference. The code is already up on GitHub, including the data set, so it's very easy for you just to fire up a Jupyter notebook and play around with the data. So. Our data set, it's an extremely exciting data set we're working today. It only consists of a timestamp and a temperature as a float. And that's it. That's all we need for the first part today. And we can see what we can do with that. So yeah, let's read it in. It's a CSV file, so it's very cool. It's so we just use the built-in read CSV method, read in our data, and say it hasn't, our data hasn't got a header. Usually pandas, like reach CSV, expects a header row. So we're ignoring this. And there's our two built-in functions. One is head, and the other one is, guess what, tail. It's like in Unix. And we just print the first 5 rows of our data set. And we see basically these are the data actually being in our file, and we already see pandas has added something. So we have a column names, or basically just like an index, numbers, and we also have an index here. But we go deeper in that in a minute. So reading data in and out in pandas, it's usually like there's a convention, import pandas as PD. It's like, as if you stumbled across NumPy, it's like familiar, like import NumPy as NP. So that's like a convention. It's most commonly used if you see any pandas examples around in the web. I just showed you like a read CSV example. It's very flexible. I mean, pandas is a very mighty super Swiss knife, which can be very can say confusing if you start working with it, because only the read CSV function has like 40 parameters you can pass in, because there's like a function for everything. Like after 1 year working with pandas, I was really lucky. I discovered something useful for me which was not built in. You can very explicitly say what your data looks like. So pandas is very good in parsing and guessing the data. For example, in our data set, that's a float. It's a timestamp, and it automatically translates it. This is not always useful, as we can see later, but we can be very explicit what our data types are, what we already know our data set, and how we want our data to be represented in pandas. So the really nice feature is, other way around, sorry. Other way around is you can immediately plot within your Jupyter notebook. You can immediately plot your data. It's built in. All we have to do is import matplotlib and pass in matplotlib inline. So it's being displayed directly in the Jupyter notebook. That's the trick %matplotlib inline does in Jupyter notebooks. And we see this is our data frame where we store our data. This is just like a simple slicing, give us the first 100 rows in our data set, and all we do is just like plot. And the rest, and by default, this is we get a line plot, and this is how our data set looks like. It's just like, it's very simple. It's all built in. I'm not going too far into visualization, because it's a topic for itself, but just like I want to share some examples what's built in. You have bar charts, area charts, distributions. You can also the plot function returns the AX object from matplotlib, so even you can improve your graphs really easy with just working on the AX object, and you can, for example, just add a line. So here I just guessed what's like the average temperature in our data set, and I said, okay, I'm too lazy to calculate, and so it's 16. Let's put a line there. So, and we will see how good my guess was. So that's it for visualization. Matplotlib comes basically built in, but you can also you can customize and your data plots as you wish, but you can also use alternatives as Bokeh or Seaborn. They're a little bit more modern. They have many other types of visualization, and they also like Matplotlib looks to me a little bit always like from the 80s, although it's one of the most fantastic libraries in Python. But these have more like a modern web approach for visualization. So I'm mentioning data series and data frames probably already all the time, and you wonder what's a data frame and what's a data series. So let's go a little bit into the structure of pandas, because pandas is heavily inspired by the R language. And the R language features data series. So for example, we just have, this is just one column of our data. So in some data set. So this is one column of data. A column with index data added, which is just like here, just like a positional index, is called a data series. So a data series is not just like these numbers being in a column, one after each other. It also includes an index. And so what's a data frame? Data frame is quite simple. A data frame is just like a collection of multiple series. And as you see, they all share the same index. And because I was lazy copying, they also share the same values. It's just like the very simple. A data series can be multi-dimensional, so it's like you can do a lot of stuff with that, but we're focusing on the simple data series. So the structure of a data series is one-dimensional. It's basically a labeled series, something data with position or a label. So it's not necessarily just numbers. You could also put A, B, C as a label there. The index is automatically created. When you import the data, you can delete the index as well later if you want. You can re-index. I'll show you later. Important is, because this is probably a little bit unusual for the Pythonista new to Pandas, we only have one data type in a series, because that's where the performance comes from. So we have strict typing for each and every series. The typing is done via NumPy, so if you're familiar with the NumPy data types, they're the same. And if you have a string, strings are stored as objects. The data types can be transformed dynamically as you wish. You can take a series, change the data type, do calculations and save it back if you want. And also on import, the data type can be explicitly set if you want. So let's see some more examples. So this is just like the pandas. We just like create a new pandas series, and all we pass is some random numbers or floats from via NumPy random, the NumPy random library. So, and here we just print out the series we made. So as you see, we have automatic data type, what is the float 64. And yeah, it's just like a simple series, auto data type, auto index. It works in most cases. Yeah. The same for if we pass in some random integers, simple series, auto data type, auto index. Hey, works well. But we can be more explicit. For example, we can pass in the same integer series, but hint the data type is a float. And then pandas will, of course, store it as a float. So, and the story continues with, of course, we can also create the index. And here we can just like pass in function, basically, just like to 0, 5, 10, just passing something, create something on the fly automatically. And the same we can do, for example, this is just like a string and something we can iter over, and we can create these labels on the fly as well if we want. Of course, we always need enough index labels, so we like the number of index labels should be more or equal to the number we expect in our data set. Otherwise, we get an error. But yeah, so how can we access the data? And this is for me in the very beginning. This looked a little bit odd because like we know how we can access data like via dictionary in Python, but we have the same syntax for accessing data in a data series. So basically this is quite simple because it's like as we used to in as we are used in a Python dictionary, we just passing a key and we get returned. And the same applies for we ask for A in our index and get the corresponding integer back. We can also just pass in the index, an integer as an index and get the same. And here it gets a little bit more fancy. We can also ask explicitly for multiple labels and get multiple backs. And so we only ask for A and D and miss B and C. So access, we are multiple, and then a special label assembles. The same applies for a range. I think you get the idea. The same applies for like explicitly explicit positions in our data set. So 1, 3 is BD. And of course, and this is like really fancy, we also can use a lambda function and access via Boolean index. So basically, this lambda function just returns whether x divided by 2 is 0. And we ask for, in this case, this returns an integer, so we get basically the same back as here. So, but this is really handy. You can also build more complex lambda functions if you want to access certain values in your data set. But there's also a method for this. This is just like the shortcuts you use in daily business, and these are the functions behind it. So there's lock to access the index by label. So this would be passing in A, B, C, and plot. And we can do the same with iloc. Iloc is just like for index location, and we pass in an integer and returns the same. And then we have, for the lazy among us, we have .ix, and this is just like index guessing. So, but it's not as fancy as it might look. It basically just like, it checks the index first for the label, and if the label does not match, it just falls back to the position. So, yeah. So, try lock first, and if not lock, iloc is ix. It's very simple, but it's handy. Yeah, but sometimes this can be really overwhelming to beginners because this is, in a way, there's so many ways to do the same in pandas. Something else which is really nice if you work with a bigger data set and you want just to play around and explore, you have built-in sample functions, so you can just ask for a number of samples from your data series. And series also can be given an explicit name. So, for example, like if we want to call our series some data, we can just pass in a name and it gets some data. And once we print it, we see, oh, we have a name now. So, but basically, and the names are basically like column names, and this is like in pandas, we have data series and data frames, but since table calculations are very present in the minds of most people, very often or most of the times it's being referred as rows and columns, although it's different. We have series, vertical series, and not like horizontal rows stored in pandas. But don't get confused, it's like used as a synonym for series and frames. So how can we, I showed you how we can select data. So we have like slicing, as we know from Python lists, for example, just like to get a certain part of our list. We have a Boolean indexing where we can pass in a lambda function, or as we see later, also like other functions to filter our data set. I've explained to you like series ix, iloc, and lock, and we already also seen sample already. So we've covered the series. What's next? Data frames. The data frame is quite simple. It's a two-dimensional labeled data structure. It's made out of data series, 2D NumPy arrays, or made out of other data frames. So basically, we can put a lot into data frames. The same applies. The index is automatically created, and basically the index tag glues together the series. So all the series have the same index, and this is what basically keeping track of the rows. Then the index is very important in pandas for accessing the data. It's being created. If you don't give an index, you can delete it, you can replace it, you can recalculate it. It can have many types. It's not just like a position. It can be a timestamp. It can be a time range even, which it's quite fancy, and it can just also have just a label. If you have a database background and have like an index in mind, that's something like an ID, and this should be unique. Be aware, the ID is not unique by default. So you don't get an error. Of course, if you import something and have the index set automatically, it will be a sequence. But if you, for example, remember our dataset with the timestamps and the temperature, if I just say make the timestamp an index, and the measurement, we have two measurements at this exactly the same timestamp, we would have like a duplicate in our index. So that's a little trap. But there are also many useful use cases for working with data like that. But yeah, maybe I can talk about it later. Let's skip it for now. So now I'm going to have more examples, how we can work with series, how we can do calculations, how we can deal with null values, how we can get rid of them, how we can replace them, and method calls directly from series and data frames. So remember our really fancy timestamp temperature data set. As you remember, we had like a 0 and 1 because our data did not contain any header. But we're humans and we like to give names to everything. So we can just add column names by passing in dot columns and just pass in a list. And the list will basically just like in the same order name the data frames, the data series with the names we pass in our list. And now we have timestamp data and the temperature. And we can immediately plot it. And this is where it's really handy. You don't have to do anything because we now even have a label. Yeah, if the data series has a label and we plot it, it's automatically added to our plots as well. So you can save a lot of overhead with plotting. You don't have to be explicitly name or data series to be plotted. It's all built in. So let's create some function. Sometimes I really have trouble with Fahrenheit. I don't know how about you. I really have trouble like Celsius, Fahrenheit. It's feel like total different. So I never understand Fahrenheit temperatures. So let's do an experiment. This is like the Fahrenheit function. So Fahrenheit, you can transform Celsius to Fahrenheit by multiply by 9, divide by 5, and add 32. And usually, I know this is the formula we'll get, you can say, let's see whether we can make like a rule of thumb, because I like stuff if I go abroad or so, I know like the currency, is the same as euro, and I can divide by 3. It's really handy. And let's see whether we can do something like that for Fahrenheit and Celsius in pandas, just like to get an idea whether we have for like human usually like regular temperatures during day and nighttime, whether we can have some rule of thumb. And just like calculate it here. So how can we do that? We create our just like a regular function. This is our data frame. We create a new data series, or we add a new data series to our data frame. And we just, we select the temperature from our data frame. So this is the temperature data series. And we apply the map function to it. And we just pass in the function we created here. And we get returned a new data series with the result. Yeah. That's, let's store this, because this is a little trick you have to be aware of. Usually, everything, if you work on data series and data frames, they return a new series in a new data frame. If you want to save something to your data frame, you have to be explicit, instruct pandas to do so. So here this is our data frame. We just say, okay, add a temperature Fahrenheit, a new series to our data frame, and just use what we get returned from mapping the temperature data frame to the Fahrenheit function. And this is actually what it looks like, and that's not too bad. So yeah, this is just like the same. We can also like use apply and pass in a lambda function. If you don't want to have if you want to have like if you don't want to add an extra function for that, it just does exactly the same. And let's now create our rule of thumb. Our rule of thumb is a very simple division of the Fahrenheit and the Celsius temperature, and we create a rule of thumb series and add it to our data frame. And here we see our rule of thumb, which is not too bad actually. Yeah. Let's describe. Let's use the describe function. Describe provides statistical insights into a series and like the basic statistical stuff. So we see we have 4,000 data points. 3.9 is our mean, which is good. Fits very well to a rule of thumb. We have a minimum, we have a maximum, and these are like the quartiles, how the data is distributed. And we already see this is a little bit off because average 4, the maximum 17. So let's take a closer look. The bad news is this is a really bad rule of thumb. I still have to deal and use my iPhone to get the right temperature if I'm abroad. And once we for example, this is how can I get rid of my bad rule of thumb because I think it's annoying, so I want to remove it from my data set. So the first thing I can do is, for example, just I want to mark it, this is bad. So just rename the column, and renaming column or a series is really easy. You can just use the rename function on the data frame, pass in a dictionary. This is like the current name, pass the new name, and important, in place true. Otherwise, remember, it returns a new series if you don't explicitly say in place true. We chose in place true, and we just have this renamed. And of course, we know it's not really useful. Let's drop it. We can drop a series from our data frame. Really simple, just with drop. And also, remember, in place true. Otherwise, we just get a new data frame back with one column less. And but we want to work on our original data frame. So, okay, so we've seen some functions and how we can actually modify data series and data frames. Very important is to remember they return a new series if you don't explicitly say in place. But there are many cases where you just want to have data from a series and actually store it in a new variable. So that's well implemented. And with drop, you can just like remove a complete series from your set. Okay, what else can we do? We can mangle and aggregate data, and it also has powerful aggregation data functions. So we can use the group by function, which is similar as a group by in a database. So we just say, please group the temperature. We also could pass in multiple series with a list here, and just apply count as aggregation function on our group. And this is what we get. So this is basically the distribution or how many measurements of each of the temperatures we have in our data set. So it's really simple. It returned a new series. So now see about the deviation of our temperature. So basically, how much is the temperature moving across our data set? It's also like really simple. We can just like calculate it. We don't even need a fancy statistician function for that. We can just take one data series, the temperature, and subtract the mean, another data series. This is the temperature, but we just use the mean of that. So basically, this is like an aggregation. We get a new series with the mean of the temperature, and we subtract it from each and every data point in our series. Yeah. So this is a very important and powerful concept that you can work basically with scalars. So basically, you can take a series, you can multiply another series, you can subtract, add, whatever, and that it's very simple. And so we have our deviation, and we can see plot our deviation instantly. It's very simple. There are some differences. For example, when you describe data, for example, if we do describe the timestamp, we see, oh, okay, this is odd. We just get a count, unique values. So you see, basically, we have the series unique, top frequency, name, timestamp. It's an object, but timestamp shouldn't be an object. So we see, so it's really easy to figure out what's actually stored in our data set. On import, we decided, or pandas decided to import this series as a string, and strings are stored as object. And for example, if we take the temperature, we see, oh, we get much more insight into our data with basic statistical functions, because it's a float and we can basically calculate something on it. So, and we can describe our data set even more. We can be more explicit and say percentiles. You mean, remember, like let's go back if you're not into statistics, that'd be a little bit more precise or explicit. These are like the quartiles. So basically we take our data set and say, this is like the part being from 0 to 25%, this is 25% to 50, and so basically we have like 4 buckets, and we see have insight about the data being in these 4 buckets. So, but this is like an equal distribution, and that's probably not really useful. I mean, if you know you have data only in a certain range, you want to be you want to be more explicit, or maybe you say, oh, I'm very interested in all temperatures beyond 40 degrees are very important for my use case. So you can see, you can even add like custom percentiles. So basically just instruct, okay, there's like a 10%, 50%, 60, 70. You can be very creative and do what you want. And you can, just like mangle the data and see your percentiles as they basically fit best to your use case. So this was like just like the basic data aggregation in pandas. This could be probably like a talk of its own. So we have described, which is important to see inside, also to find bugs. For example, you expect a timestamp and it's actually like a string. We have scratched grouping, so you can group by one series, you can group by multiple series. You can get means, sum, medians, and get a really very good understanding what's actually in your data set. So what's very often bothering is null values, because so that's why we're looking a little bit more into how pandas is handling null values. We can actually ask directly. We are just like the isNull method. We just pass in our data series, ask isNull. This returns a Boolean index, so it returns like a 1 for each temperature where the temperature is actually null, and then select this from our data frame where we have a match, and we actually see there are 3 timestamps with a null value. And I think it's always annoying to do some calculations and you hit null value and you get an exception. And in big data sets, this might happen. This is some random sensor data. It's likely. And with is null, you can basically identify. You can also even look for it. So I even figure out where it's located, or at least one with getting a new series and with some slicing. And we can also do like a really simple test with just like asking for is null and is any true. And then we know, okay, there's some null values. And let's look a little bit deeper how pandas is handling actually null values and what you can do about null values in your data sets. First is you can basically, you can drop them. Can remove the columns, all the entries from, but it's important if you say drop NA, it will not just drop the single value, of course, it has to drop a row from the index. And the same applies here with be aware drop NA will return a new series unless you say in place true, if you want to work on data series you're actually working with. But for example, for the describe, for example, ignores values. So once you explore the data set you have with the describe function just to get some basic statistical insights, it's ignoring them by default. Although in one pandas, I think in 18.1, there was some bug and it did not ignore. Usually I'd like to remove them. You can also pass in a function to replace them by a default value. You can also do interpolation, depends on your use case and how dramatic, thank you. Basically your data set is. Null values are for you. Okay, so this was end of part 1. So everybody who knows pandas already, please wake up again. So we've seen we scratched data series data frame. I hope you have a good understanding now about the data structure in pandas. We've seen I/O, how to read data in, and of course I didn't provide example, but you can also export to Excel, CSV, any data to all the commonly used data formats. So it's really handy to get data in and out without any trouble. We've seen data analysis, indexing, built-in visualization, and how you can interact with your data. Okay, part 2 is a little deep dive, or a little deeper dive than the introduction on time series indexing and the index. So I very often have data and there are some timestamps, and usually the timestamps is a very important part of the data. It's not just like some extra. You can instruct pandas to convert a series to date time. It's built in, but of course this is some of the odd stuff in pandas. To date time is, of course, it's being built. It was built in the States. It's US date friendly. The US is the only country in the world, you probably are aware, month first, day, year, which is odd. But so be aware. But it's no problem because pandas has built in almost anything. You can really say explicitly, this is the date type in my date set, and say this is the formatting, and you just can use standard date time formatting as you most probably are familiar with. So let's do some examples. So let's create an index. You remember our timestamp was actually a string, and let's make that string datetime. And lucky me, pandas is not by default US, it's only US date friendly. For this time series it worked really well that pandas realized it's European date time because it's from Denmark. And you immediately, if you remember the plots we had on our data set before, they were like this, and now if we plot just like the name, we just added an index, our plots get smarter already, because now the index gets our data set ordered for the plots, because now because these were our data from multiple sensors, and now they are all ordered by the timestamp, and nothing we actually had to do except for adding an index. And it's also like very easy, just like for example, to add a median. And as you remember, I guessed 16 degrees as a median, and we say, yeah, well, it seems I wasn't too bad, but we can also just like add another line and take the medium, the actual medium from our data set now, and just add it here, and we don't have to worry about adding any extra values or positional data. It's all sorted out via our time series index. So I think this is really handy. So let's have a look. Again, our data set, this is what we are working with. And let's take a closer look at the index. So we can also access the index data via df.index view. And we see now our index is a date time index, and these are the actual values. And we even have some basic insights here, like the number. We don't have a frequency here. I'll show another example later. And yeah, we can really look into it. You can also just get the index and export it if you're just interested in the timestamps. You can access it as any data series. We can just now group by. We can also group by the index, and this is very powerful because the index, since it's now a date time index, we can just group by date. We could even say year, month, all the commonly used how they say date formats or like yeah. So basically, we can just pass in date for the grouping and count how many measurements. Of course, in all columns they are the same, but these are so we see on this day we have 66 timestamps in our data set we can work with, and it's really easy, and it's all done by the index. And I could do the same just by passing in month instead of date, and have the same aggregated for month without any extra group by, without any extra functionality. And this is what makes the datetime index so powerful, and because it saves a lot of work and overhead and code actually, yeah, and possible mistakes. So we can just plot the same just by median. Yeah, probably what we expected. And as you see, we also can just have our data aggregated by week, just by working with the index and choosing week. And you can also do something like this. It's probably not so useful if you don't have a special use case for it, but we can even ask for the weekday. So please, this plot only returns the values of the weekdays and returns the temperatures for the weekdays. So we're missing the weekends. So now we know it's really easy to figure out. Is the weather at the weekend always not as good as during the weekdays? Because sometimes it feels like that. So let's have a look at our data set and find out. And it's really easy. It's basically just like a three-liner. So we save the weekday via the index. We select all the temperatures from the weekdays. The same for the weekends. So the weekends we can just select by is in like this 5 is Saturday, 6 is Sunday, and this is something really odd because it's not like as the US date. This is US friendly. Hey, this is very European, yeah, because usually in the US Sunday is the first day, and here we have a range from 0 to 6, and so Monday is the first day. So, and that's probably not obvious because you cannot rely. Oh, it's all US. This is how we like it. So, and then easy, we can just do pass in a group by, index by the actual hour, so we see how the temperature behaves during the day, and get the mean. Unstack is just because we have a nested grouping, we just want to simplify it and create a new column for plotting here, and then just plot it, and we see, okay, actually in our data set, the temperature at least is a little bit higher even on the weekends. So, but it's it's not really relevant because it's a very small data set. So it's just like for demonstration purposes. So. Okay, but you get the point where how you can access it. And the same applies for dates or month. We can also select data for September of that year, just like by passing in the year and the month. Of course, this works for day, hours, whatever you want to pass in here, and just like get the values returned from the index. So this is really fun working with timestamps with pandas. So, and of course, and this is, I think, super fancy. You can also select a range. So just if you're just interested in a 2-day range, we can just pass in 2 strings and use it like we select other ranges from lists. Also, it's like super cool, and it fits very well in the syntax. So. So, and of course, we also can do some stuff. Yeah, we just can also like work with Boolean indexing here. We can also ask just like for values where the actual hour is greater than 12. So actually, we're just looking at data from the afternoon. And basically, actually, we're passing in 2. So we're actually just looking into like the midday, afternoon until early evening data and get the data plotted from here. So you can even have closer looks if you, for example, have data from a machine and you see a machine has like, it behaves odd at some times. So you can just like have a closer look at the data and see how they behave. And you can do like a very explicit selection via the index and even just like do stuff like this, which I think really nice to do stuff like this with just like 1 line of code. And last but not least, we can even resample the data. So if your boss, your manager, if somebody from the company you work with asks for, hey, I want to have a nice aggregated report, and you say, oh, I have pandas, but I would like to do a pivot, but I see something like a pivot table, yeah, and I need to aggregate this stuff. But it's really easy to resample data and do reports on a daily basis. So basically, we just like resample our data set. We have look at the days, and for each and every day, we just take the maximum value, and this is like the maximum temperature for the resampled days. We can do the same for the month. We just pass in month, and there's a okay, that's not a list yet. And of course, we can just select what's that? We can just like get the minimum and maximum aggregated via the .agg function from our resampled data set. So basically, this is the temperature range min max for each and every day. Again, this is just like a 1-liner, no further aggregation needed. We can even resample by, I show you like what you can pass in here, just in one of the next slides. We can also pass in 3D, which is actually 3 days. Yeah, I don't know whether it's useful to have sets of 3 days in a row, but just like for demonstration purposes, you can be really flexible here. So we can have like, that's like the mean over 3 days and just plot it. So resampling, Pandas has a financial analysis background. Like Wes McKinley, he worked at a financial analysis company when he started creating Pandas. So you have, I think these are like for regular humans, most useful codes, like for annum, for year, or by quarter, month, week, day, and all this. But you also have a lot of like the financial stuff, like business day frequencies and quarter start frequencies. And to be honest, I only understand half of them. But yeah, but it's very powerful. This is the code set. It's actually was not too easy to find online, actually. So what else? if you remember, there was some when we looked at our data frame. How much time do I have left until you shoot me? Yes. Let's show this and shorten the question. Yeah, you can ask questions during coffee break. No problem. I'm around. So let me show you this. We mentioned like the frequency, and the time series index can also have like a certain frequency. And to demonstrate this, let's just create a random series and pass in as frequency seconds. And this is how many periods we have. So this is like a time range of 1200 seconds. We are just creating, and we basically we create an index. We are a range, and the series is just like pick something random and for our data set, and this is how our random data set looks like. And you see we have an entry for each and every second, and this data set also has now a frequency. And if you have a frequency, you can even do more fancy stuff. For example, you can resample your data. So let's resample this for like 5. It's good. I forgot. Okay, let's resample it by something. And you see, and then you can even say, because like if you remember, we did not start. This was not the start, so there was a gap, and you can even instruct like how to deal with the data if you only scratch a part of I mean, you have like we resample by we put data in buckets again, and in the first bucket we only actually have half because like we don't have any data here, so we can evenly instruct by while resampling where we want to close, whether we want to deal with this data or whether we want to basically have it filled. So I'm sorry, I have to hurry up a little bit. So you can also upsample data. So you can resample your data and pass in a name. But wonder where's the point in upsampling data? I mean, why add data which is not there? Sometimes if you miss data, this can be useful. And Pandas has many built-in fill functions like pad, where you can say just like you see this is just like a forward fill. So here we're missing 2 data. We construct, okay, just take the last data that you know, the value you know, and just forward it until you have a next value. This is forward filling in statistics. Of course, you can do like backwards filling with bfill. You can even build your resampler. So if you know, you can basically create your own interpolation. So you can instruct how to fill the gaps. And usually, in most cases, if you have a huge data set, it's quite easy to figure out how the values most likely would have been in your gap. But so you can actually like highly customize your interpolation to fill the gaps, and not just like forward fill, backwards fill, or take the medium or do something linear. But just yeah, so you can totally adapt it to your use case. So actually, this was my talk. I have one commercial break. I have to skip this. I'm sorry. But it's in the slides. So I have a little commercial break because EuroPython is coming up, and this year we're doing EuroPython together with Python Italia in Rimini. So if you can't get enough of conferences, in July, in just like a few months, we'll be in Rimini in Palazzo Congressi. The call for papers is open, so if you want to participate and submit something, please do. It closes Easter Sunday, and we also have a PyData at EuroPython. And yeah, that's it. You can download the slides. Oh no, the slides not. I'll tweet the slides, but the code examples are on GitHub, where you can basically play around with the data and the Jupyter Notebook yourself. Yeah, thank you.
There's any question? There's 5 minutes, so we can.
Hello, I have a question about comparing one year to another year. So if I want to find out if it's warmer this year compared to last year, do I get anything inside Pandas for free, or do I have to do it all myself?
You can, it's built in Pandas, so I would just like take one series, select 1 year, and subtract the other year Like if you have one series both years, you can basically just like make a selection, select. If you have a time series index, you can just like select dot year is 2015 and do the same for 2016 and just subtract it to a series. Yeah. Of course, they have to. Yeah. Basically, you probably have to pre-aggregate it to a month or so, because the first subtraction they need to be in in sequence. Yeah. Yeah, they need to be, of course, like for example, you need some ordering because, like, for not to subtract like December from July or something. Oh my God, this is like Armageddon is coming. Yeah, something like that. Oh, sorry. Yeah. Okay.
I have a little question. Yeah. In pandas, when we are using Python 2.7, there is a encoding inference. And when we are using 3. something, the encoding inference is just gone.
Okay.
So when we are getting data from CSV, and we don't know what is the encoding, this is just pure mess. Do you have some?
That's a good point. Actually, I've never stumbled across that, but actually, like, probably the best would be to check the encoding and rewrite the file. It's hard to say something is not built in pandas because there might be something built in actually, but I don't know. Yeah. Yeah, but I think that you can just like figure out by try and error. I know encoding is one of my favorites because it's always like a mess. It's like.
At the very beginning of your talk, you mentioned suggest to use pandas for data files until a certain size. What do you mean? What is the limit?
You see it. You see in this slide. Admit it. Okay, yeah. This is actually this is a citation from Wes McKinley, who is the actually inventor, and he says pandas works well with 1 gigabyte of data, but not as well with 10 gigabytes. So, and definitely there's like the limit is also the RAM on your machine you can actually use, and they're already working on it for Pandas 2 version, which is, I think, coming. They're already planning on it. What I can suggest, if you have a really big data set, or if you want to stream data, and if it's like, for example, like a time series data, you get data from a sensor, and you know it's already like in a sequence and in a sorted fashion. What I suggest is read data in chunks. So basically, get like 1 gigabyte of data, make a grouping, some aggregation you're looking for, save this part, get the next chunk, and then basically collect the chunks and create with and then work with pre-aggregated data. That's what I would suggest, yeah, because it saves RAM, and very often you only look for like few values, and it's not always of essence to have the complete data set at hand all the time. So that's what I would suggest, like read chunks, group, keep them, and actually you could even like do this in the streaming data. Yeah, you could keep pre-aggregated results for like a certain time and just reslice them and put new in, throw some old away. So this should work with pandas.
All right. Yeah. I have a question left.
Yeah. Hello.
Can you tell us about the performance? For instance, if I want to aggregate or group 1 giga of data, is PostgreSQL faster than pandas, or is pandas? Why should I use pandas? That's
oh, actually, I have no direct comparison, because it depends on the database you're using. So I think it's hard to compare just by this is a database, this is pandas. I mean, pandas reads the data to your RAM, so it should be always like really good. But modern databases keep data in RAM as well. So, I actually have never seen a comparison. This is one database and this is pandas, but because I think in most cases people read the files. So, just like to turn the question around, would it be more efficient to store the data into a database and then do the aggregations? I'd say I don't know, but probably try it out and give a talk in EuroPython about it. Uh-huh. Yeah. Yeah. Cool.
Well, I was sitting next to a database admin. I was sitting next to a database admin, and we needed to do a mean on some data type. He had exactly the same data type as me, and I was using pandas. Mine was like half a second later, so it's not sensible. PostgreSQL is faster. It was like on 15 gigs of data, and it was only half a second late, so.
Just to add this small comment, group bys in pandas are pretty quick, but depends on what you do on them. There are very sophisticated functions with a lot of overhead. The pure group by mechanism is considered to be very efficient.
Okay, thank you so much again.
Yeah. Thank you.